All right. So let's start again.
Okay.
Now we have this displacement. This is given.
Okay.
And this RD is also given.
Yes.
The relative density is 1.010 and the displacement is 12,200. That is in dock water.
Yes,
So
sir.
we assume that there is some X amount of hydrostatic draft here and it is same here. This is assumption. We assume because it is going to help to find out the values which we need to have. All right. So after assuming, we realize that underwater volume is same, right?
Right.
Because hydrostatic draft is same. That means displacement is going to vary as relative
Relative
density.
density.
Now we have the value of 12,200. We need to find the value here. So what we have to do? We need to find, we need to do the reverse calculation. So how to find out? We need to multiply by this column.
Yes, sir. 1.025 divided by
0.25 and divide by, we are starting
1.010.
1.010. Exactly. This is what we have done here. So we got this 12381.2.
Yeah.
This is the display. Now there are two ways. We can directly start with this, or we can start with equivalent hydrostatic draft. What is equivalent hydrostatic draft? So for that, we need to come to this 123. How much is the value? 12381. 12381, 12383. So it is going to vary
somewhere
between 6.6 and 6.8, right?
No, sir. 12381, right? Sir, it's between
Sorry.
6.0 and 6.2. 6.0 and 6.2.
All right. Okay. I made mistake. 12019, 12472. So it is going to vary between 6 and 6.2. So
yes,
there are various ways to do the interpolation, because I find sometimes the guys get confused with this interpolation business.
Okay.
So one way of doing this is, let me just show you here. So let's write draft here 6, right?
Yes, sir.
For
Yes,
6,
sir.
this is 12019 displacement, 22.47, 174,
72.96.
72.96,
Yeah.
2, and
That's not constant.
72.476, and then
3.20.
okay, I think we'll go to the next slide or what?
Okay.
Lack of space here. Anyway, let's start with this only, right?
Okay.
So that we understand the basics. And the next is 6.2.
Yes, sir. 12472.
12472.
22.56.
22.56.
175.7.
175.7.
72.916.
72.
No, 72.941. Sorry.
941. Okay.
Yeah.
And 72.33.
Yeah.
There has to be some variation in the system. All right. So here, what is the difference? 0.2.
Yes, sir.
And let's calculate the difference. If we have Excel sheet, nothing like it, but in exam, it's not allowed. So we need to do it manually. 12019 minus 12472. How much is this? 453, right?
Right.
And this is 0.47 minus 0.56. 0.09.
Yeah.
They're all increasing actually. Some particulars may be decreasing.
Yes.
This is
1.7 increasing.
1.7 increasing, and this is 0.9.
21. 0.021.
0.021. 21, but this is decreasing.
Decreasing, yeah, decreasing.
Decreasing. Just put a sign, whatever,
Yes, sir.
so that you know you don't make mistake. Here again it is decreasing.
LCB and LCF are decreasing. Okay.
476. Okay. How much is that?
133.
143. 0.143 decreasing. Right?
Yeah.
Now the value which we intend to calculate is 12381.2, right?
Yeah, right.
12381.2.
Hmm.
This is what we need to calculate. So what is the difference?
So let me-
12019 minus 12381.2. 362.
Yes, sir, 360.
So how to calculate? This difference is 362.2.
2.2.
Any idea?
Sir, unitary method
Yeah.
for 0.2, it's 453. So sorry, for 453, it's 0.2. So for 362, it will be like
Correct.
0.
So let's start here. 453 is 0.2. For 362.2 will be what? Right?
Yes, sir. It will be multiplied by 0.2 upon 453.
So what we have to do? We have to multiply it by 362.2.
Yeah.
Multiplied by 0.2 divided
0.2
by
upon 453.
453. So what we get?
Let me check. 362.2.
362.2 into 0.2 divided by 4.
0.159.
0.159. 0.1599. Actually, if we round off, it will be 0.16.
Yes, sir.
Yeah, it's very much possible. Okay. And this is increasing, right? So we got to add
Yeah.
here. So it will be 0.16.
6.16. Yes, sir.
So we can calculate all the values for 0.16 here.
Yes, yes, yes. Okay.
Correct?
Correct.
And the moment you got 0.16, it is similar to this question, previous question.
Previous question, yes. We already got the hydrocyclic half. So, yeah.
Correct. 6.16. Now 6.16, you need to tabulate these values and accordingly keep working.
Yeah, yeah. Okay.
And you need to work only up to MCTC.
Yes, okay.
Okay. So I hope you are getting this hang of the changing the values.
Yes, sir.
And let's come back here. Right. So usually there is no need to calculate this.
Okay.
We start from here only. Okay. This is the hydrostatic draft, the displacement, and this is TPC. Let's start
TPC.
from the TPC. Very important.
Okay.
So 453 is equal to 0.09. So
Yeah.
362.2 is equal to 0.09
divided
by
453. Okay.
362.2
It will be
0.09 divided by 453. Haji, 0.071.
0.071.
Whatever the value we get to add here because it is increasing.
Increasing, yes. Okay.
Plus 22.47. So we get this value 22.54.
Yeah.
And keep it in two digits of decimal. Okay.
Okay.
Like this is 22.47. Actually, the value I'm getting in calculator 22.5419. So no need, just round off to this.
54. Okay.
So we got the value of TPC.
Okay.
By the way, this TPC is for what? This is for salt water.
Salt water.
Now, if I need to convert to dock water, what to do? 22.54 into
1.0.
10 divided by 1.0. You get the final thing. Clear?
Okay.
And the next is MCTC.
MCTC.
And after that, there is no need to convert. The values will remain same.
Okay.
I mean, you need to find the equivalent value here.
But sir, this LCB and LCF. Okay. They are constant. Okay.
Are you getting? You need to
Yeah,
find this value. I mean, let me just mark with green color. You need to find this value, right?
Yes, sir. Yes,
Like
right.
22.4. And here also whatever value you get. And here also whatever value you get. And here no need to convert to the dock water thing because it is dock water, salt water, same.
Okay.
But here it is different.
Okay.
MCTC.
Okay.
I hope you are able to recall. Here I discussed these 4 parameters. 1, 2, 3, 4. Rest everything remains same.
Yes, sir.
Is it clear now?
Yes, sir. Now clear.
So what we'll do as a priming exercise, we'll start with this question. Okay. And I'll explain, and
Okay.
I would suggest you just make effort and do this question.
Okay.
MV Hindship.
Okay.
Let me first explain. MV Hindship arrives at a port at even keel draft of 6.70 meter.
Okay.
Where relative density of water is 1.010. Okay.
Okay.
She sails at a draft of forward 7.2 meter and aft 7.3 meter. Now we are not even keel after sailing.
Yes, sir.
There
Yes,
is a
sir.
trend. In this port, 120 metric ton of fresh water was received and 40 metric ton of fuel plus fresh water was consumed. Calculate how much cargo was loaded.
20 minutes.
Okay. So suppose there was a displacement, arrival displacement. See, the ship arrived, there must be some displacement, right?
Yes, sir.
And after that, what operation we did? We
Loading.
loaded of some fresh water. So we loaded 120 metric ton of fresh water. And on port, you are going to consume some fuel and fresh water. 40 metric ton you consume. That is minus.
Okay. Okay. Yes. Okay.
Then you loaded some cargo.
Okay.
By arrival displacement plus load.
Yes, sir. Yes, sir.
Plus
जो add हुआ वो
load minus discharge is equal
plus
to
cargo.
final displacement.
हाँ ठीक है सर ठीक.
This is final displacement. Is it that difficult to understand this equation?
No.
Very simple. Suppose you had 100 rupees. I gave you 50 rupees more. And then spend 10 rupees further. Then you should know what is the final value. It is as simple as that. Right?
Okay.
So now tell me what parameters you need to have if you need to find this cargo. This is given. This is given.
Yes, sir.
So our target
Displacement
is
arrival.
and
Yes.
this, correct?
Yes, sir.
So let's find out.
Okay.
Arrival. What is the draft?
6.7.
6.7.
Okay. It's between
Even keel है, तो इसका मतलब
Yes,
क्या
sir.
है?
Even keel. Hydrostatic draft भी same. Yeah.
Okay, that you should be knowing. That
Yes,
if
sir. Yes,
the
sir.
vessel is an even keel,
Yes, sir.
center of flotation is almost
6.7.
whatever it is, but trim is 0. So obviously the hydrostatic draft is same
Same. Yes. Yes, sir. Yes.
as even keel draft.
So 6.70. So, sir, we can take the value in between 13383 and 13840. We can just add and divide by 2. Can we do that?
What is that?
Sir, we have values for 6.6 and 6.8. So for 6.7, we can simply just add the both displacements and divide by 2. Can it work?
Yeah, it can work. It can work. Now, we need to find out displacement, right? That is the target. So let's see how we have found out. Same, just follow this. Dock water, right? Dock water here, right? Salt water here.
Yeah.
Dock water, you know the density 1.010.
1.010.
And salt water is 1.025. And assume that this is actually given and that you need to find out this.
Yeah.
Okay, see, assume that This is the draft, and this is also assumed.
Okay.
Now for 6.7, you rightly said the value will be given for 6.6 and 6.8, right?
Yes, sir. Right.
So you can add divide by 2 also, because that's a mid value.
Yes, sir.
You get this.
Yeah, same. Yeah, 136 on 1.5. Yeah.
Abhi, but that's not the answer now. We are in
No, that's the yeah,
we are in
arrival.
top quarter. We need to
Yeah.
find this value. So how to
Yes,
find
sir.
this value? Is 13611.5 multiplied by
1.010 upon
correct
1.025.
divided by,
1.025.
remember, wherever column you are going, multiply that RD. Simple.
Mm-hmm. Okay.
So what value you got?
Sir, it will be 13412.3.
Is the same thing or different answer?
Yeah. Cannot understand, sir. What?
What answer you are getting?
So let me add 134. Just a second, sir. 136.1.1.0 divide. Yes, sir. 13412. Yeah.
Yeah, 1341.23.
Yeah. 0.31. Yeah. Okay. It's okay.
Remember, for approximation for turn, decimal one place is good enough.
Yes. Okay.
Actual value is 3.307 in this.
Yes, sir. 0.307. Yeah.
13412
So, sir, we can take 0.31 also.
30732. If you want to take for two places, take 31.
Okay. Yeah. Yeah.
But you see the standard which we are making for turn, we are taking decimal
Yeah.
one place.
Okay.
Now look at this particulars. You will get the idea. My recommendation is you should go for these digits only. Like draft, 2 digits, decimal.
Yeah.
Okay. TPC, 2 places. MCTC, 0.1, 0.2. So accordingly, you try to round off the final answer. LCV,
Okay. Okay. For
3
one. Okay.
places.
Okay.
LCF, 3 places. So no confusion.
Mm-hmm. Yes. Okay. Okay. Okay.
All right. So we have obtained arrival displacement. Now what is our next target?
Departure displacement.
Departure displacement. उसके लिए क्या करेगा?
सर वो फॉर्मूला सिंपली प्लस 120 mp minus 1.
ट्रिम तो दे रखी है हमारे पास. एलबीपी तुमको पता होनी चाहिए.
Yes, sir.
हिंडशिप की कितनी है?
Yes, sir. LBP is.
पहले पेज पर लिखी रहती है जनरल पार्टी.
Yes, sir. Yes, sir. Length between perpendicular.
हाँ. Length between perpendicular.
143.160.
हाँ. Commit to your memory so
Yes,
that
sir.
you don't waste time in the last minute. 143.16. So
Yes, sir.
what is the formula? Remember that if you have a trim that you should be able to find out the. Okay, let me just give you recap.
Okay.
Suppose this is your vessel. And it is trimmed like this. This is your forward draft. This is your aft draft. And there is a center of flotation here.
Yes.
And we need to find draft at center of flotation. So that means there is going to be correction here. This is the correction. So correction is going to be aft draft. Tell me, I should add from aft draft or subtract in this case when we are having stern trim?
When we have stern trim, we will subtract from aft to
obviously
from aft.
If you are going from aft to forward, your draft is decreasing. So at center of flotation, it is going to be less. Minus this.
Minus forward.
Okay. I'm sorry, I wrote correction. Actually, we should write the final hydrostatic draft.
Yeah.
Minus correction. Right? And what is the value of correction? Correction is simple. There is a triangle here. This is the triangle. Okay. I think I should have chosen the different color. so that you know this is the triangle. Okay.
Okay.
And this is LBP. And this is your trim. So trim by LBP. There is one triangle. And if you see this height, yeah, this triangle, this is also baby triangle, right?
Yes.
This is correction divided by LBP. Okay.
Okay.
I don't want to teach you derivation, but that's not very difficult. So correction is L, sorry, L, this is LCF. My mistake.
Yeah.
LCF. So trim into LCF divided by LBP.
Yes, sir. Okay.
Got it?
Got it.
Okay. So now let's see. The first target should be to find LCF.
Right.
What we do, there is still assumption. This is the forward draft 7.2. This is aft draft. So let's find midship draft
Yes,
7.25.
7.25. Okay.
And for 7.25, we need to enter the tablet and find LCF.
Yes. Okay.
So 7.25 LCF. Let's come here. Okay. I think another monitor 7.25. 7.25.
LCF.
Next page. Oh, I have only one page for what?
So
Okay.
7.25 LCF. We have to, okay. We have to interpolate between 7.2 and 7.4.
Okay. Do you have the values?
Yes, sir. I have the values. For 7.2, LCF is 71.393.
See,
Okay.
what
For,
we have taken, the mean draft.
yeah,
Acha,
7.
and then let's do the working. What is the value for 7.2?
7.2 is LCF is 71.393.
70?
1.393.
393.
Yeah. And
7.3 is how much?
it's 71.39. Okay. Oh, 7.3 is, no, sir, it's for 7.4. For
Oh, sorry.
7.4.
Okay, my mistake. Okay,
Oh,
it's 7.4 is how much?
71.193.
71.193.
193.
It is much better. This is a rough work, or maybe it is you can call it fair work also. And you need to find the value at here, 7.25, right?
Yes, yes, yes.
So 0.2 difference is how much? And by the way, it is decreasing.
Yes, sir. 0.20.
0, 0.2, right?
0.2. Yeah.
Okay. So
Quite
what is the
simple.
difference? Is 0.2 and 2 final 0.5, right?
Yeah.
0.5. What will be the value? Let's figure it out.
Sir, this is 7.4 minus 7.2 is where do you get 0.5? This 0.05?
Mean draft. This is forward draft. This is aft draft. So find the mean draft.
Okay, so for not for 0.05, for 0.25, right?
See, what is the difference between 7.2 and 7.25?
Oh, okay. It's okay.
7.2 and 7.25.
Okay.
0.05, right?
Yeah.
0.5 into 0.2.
2.20 upon 0.20. So 0.05 same.
And that you should increase or decrease?
So decrease.
Minus.
Yeah. Decrease.
So how much you get?
So sir, we will get around 71.193.
No. 71.393 और इसमें 0.05 हटा दो.
Okay, so 71.34.
343 यही तो निकला है.
Yes, okay.
Is it clear now?
Yes, sir. Okay, yeah.
हाँ, थोड़ा सा it require practice and
Practice,
patience.
yes.
Girls.
Yes.
Okay. hydrostatic draft, half draft minus correction. Correction, I give you the same formula just now we discussed. Right? And LCF is 71.343. Trim is how much? 0.1.
0.1.
And 1433.16. देखो ऐसे दिखाई दे रहा है, राउंड फिगर यही आ गया.
0.050. Let me calculate, sir.
And since this is a Hindship, the shape of Hindship is almost, you see the round of the midship draft and this hydrostatic draft is almost same.
Yes, sir.
But still it is recommended that you show this working.
Okay.
Don't start with that midship draft is hydrostatic draft. No, may or may not be possible. Remember my statement that COF may or may not be at midship. So now we have this value 7.25. और 7.25 पे काम कर लो. 1.010 पे 7.25.
So 1.010, 0.25 multiply करके divide by.
Yeah, you need to do the interpolation. Just now I told you, right?
Yes, yes, yes.
And you have this value. Now you come back to this value. How you come back to this value?
So multiply by 1.010 divided by 1.025.
Yes, that's it. So you get this displacement.
Mm-hmm.
And now you have the
The
equation.
displacement we put here. Okay.
You can easily work out the cargo.
Yes, yes, yes.
Displacement 120 minus this. So final cargo calculation is given.
Yes, okay.
Okay.
Okay. Yeah.
So we'll stop here.